Okay, in earlier lessons we reviewed the properties of exponents that you should have learned in Algebra 1, and then in the last lecture we introduced the concept of a rational exponent to you. And so basically what we were discussing about rational exponents are basically exponents that can be written as fractions. Well, rational exponents have all the same properties of what we would call an integer exponent, and that's what we learned back in Algebra 1. So if you look at the following property list, these are all the same properties that we reviewed a couple lectures ago. But then you can see on this side the examples involving a rational exponent. And so you can see what ends up happening is when you use these different properties, at different times you end up having to add, subtract, or multiply fractions together. Now, you're going to have to become comfortable with the fractions being in the problem and doing different fractional operations with them. In a lot of cases, they're going to have different denominators, so you're going to have to find a common denominator. Now, I do want to remind you that your calculator will do a lot of this for you, but that does not give you the free pass on not knowing how to add and subtract and multiply fractions. So do not just rely on your calculator. You can check yourself with it, but I would not get to the point where you're allowing the calculator to do all the work here. So take a moment to just review this concept summary box with the properties of the exponents, and then we're going to go down to sample problem number 1. We have 3 different problems here for you, and so what I'd like you to do after you've given those properties of exponents a good review, to just go ahead and pause the video and work these 3 sample problems, and then come back and look at the answers. Okay, if you had an opportunity to do that, and we see sample problem 1, the first thing that you need to recognize in sample problem number 1 is that two things that we're multiplying together have the same base. So if they have the same base, that means we can put them together and take the exponents and add the exponents together. So what we would do here is we would take 5, and of course we have 1/2, and we would add it to the 1/4. Now, you can do this one of a couple ways. If you want to go through the old middle school way of creating equivalent fractions and then add them together, that's fine. If you want to jump into your calculator and do that, that's fine as well. Just be sure that you are comfortable with both scenarios, so that depending on what's asked of you, you'll be able to work it. So when I add 1/2 to 1/4, I get 5 to the 3/4 power. Now, at this point, I will be fine with this. I know we're dealing with the numerical expressions. If you wanted to, you could simply put that into your calculator. And of course, it's probably going to be a decimal, so you would have an approximated answer. So you're definitely going to need to read your directions to see if I'm looking for reduce it to the simplest terms and get an exact value, or if I want you to reduce it all the way down and get a rounded value. In this case, I just want you to simplify it to its simplest terms, so leaving it as 5 to the 3/4 power is fine. Keep in mind, we did learn how to write this in radical form as well. So what we have here is you could write this as the 4th root of 5 to the 3rd power, and those are equivalent to each other. Now, a general rule of thumb that I'm going to ask you to stay with here is if it was given to you in rational exponents, you could probably simplify it down and get your final answer in rational exponents. If it's given to you in radical form, simplify it down and leave it in radical form. So depending on the different types of problems that we're going to be working, that's a good rule of thumb to go with to start. So if we look at part B, we have a situation where the 2 and the 3 are not the same base, even though they both have a 4 there. But what we do have a situation here is that we have an exponent outside the parentheses, so that exponent has to be applied to both parts of the parentheses. So we're going to have 4 times negative 1/4, and of course if we do that, 4 times negative 1/4 is actually negative 1, and then same thing for the 3 to the 4th, 4 times negative 1/4 is also to the negative 1 power. Now, one of the things that's going to be a common expression in your directions is to leave all your answers with a positive exponent. So before we do that, this is understood to be over 1, understood to be over 1. And so to make this a positive exponent, we can just flip the two values. So I have 1 over 2 to the first power times 1 over 3 to the first power. And of course, we know that the first power is understood. And so now we can multiply these together. When multiplying fractions, you multiply the numerators and then you multiply the denominators. And we're going to finish this with the fraction 1/6. Part C has kind of a funny look to it because of the way it's written. It's probably better if we saw it more like this. So we have each of those, excuse me, that's probably not a good representation of that. So we have 4 to the 1/3 power. That whole thing is being raised to the second power. So this, because of the typeset, looks a little funny. So if you write it more expanded like that, it's a little easier to see. And so what happens here is, again, with the quotient property, this power of 2 has to be applied to both exponents. And so when we do that, I'm going to actually end up with 1/3 times 2, so that's going to give me 12 to the 2/3 power, and then 4 to the 1/3, so the 1/3 multiplied by 2 is going to give me 4 to the 2/3 power. Now, interestingly enough, if we go back up to our properties and we look at this, whenever we have a power that's the same, and we can look at this, the power gets distributed, you can actually back that out and go the opposite way with that. And I know that's a little confusing at first glance, but what we're noticing here is that this exponent and that exponent are actually the exact same thing. So we can actually take this exponent out, leave the 12 over 4, and then put the 2/3 exponent outside of the fraction. And the reason this is useful for us is because 12 over 4 is equal to 3, and then that's going to leave us with 3 to the 2/3 power. Now, that is simplified as far as we can go. If you punch that into your calculator, you're going to recognize that you're going to get a decimal answer, and so we want to simplify this to an exact value, our simplest terms, and so this is good enough. So that is a good quick overview of the property of exponents, but now using rational exponents instead of integer exponents. So in the next lecture, in the next video, we'll talk about radicals.